Hello everyone, good morning. So here we are on a science topic. Let us begin the first topic of physics, that is motion. Before this, let me just take a review of your yesterday's test. I'm sure it was good. When I saw your responses, even that was good. You need not to panic looking at your score, because I'm going to recheck your papers, find out by maybe some syntax error that what automatically generation cannot find out. So let us find out all those errors and rectify your scores again, and maybe today or by tomorrow I'll be sending you the exact result of your yesterday's test. Expecting, see, I'm not expecting the out of out scores. I'm not expecting 30 out of 30. I'm just expecting through this particular test that you must prepare and generate a kind of a seriousness in you. Okay, believe one simple thing, maths just depend on honesty. If you are honestly preparing, only and only then you will have scores on the board. So keep this in mind. Honesty will help you everywhere in mathematics. Anyway, it is not about mathematics today. Let us talk about science. So come out of your all that test and the scores and everything, and let us understand motion. In the motion topic today, we are going to understand these 5 points. One is what is physical quantity. Second is what do you mean by scalar and vector quantity. Third is distance and displacement. What does it mean by? Fourth is speed and velocity, and fifth is acceleration. And believe me, there is nothing other than these 5 points in this topic after this. So if these 5 points you understand clearly, then it's done. Okay, so let's understand physical quantities. The quantities which physically we can measure called as a physical quantities. A very simple approach of understanding physical quantities. That means if you find your weight, the weight is a physical quantity. We always have a habit of checking our height. Height is a physical quantity. We look at the time every day. Time is a physical quantity. We purchase milk from the market of half liter, 1 liter. Liter is a physical quantity, that is, volume is a physical quantity. Right? We measure the temperature during when we are ill. We measure the temperature of body. Temperature is a physical quantity. Right? So the physical quantity we normally use every day. It has got its own measurements. It has got its own measuring tool, and it has got its own unit. For an example, weight is measured in kg or in gram. Height, it is measured in centimeter, meter, centimeter, meter, maybe even kilometer sometime. Like height of Himalaya, it is measured in kilometer. Distance measured in centimeter, meter, kilometer. Volume is measured in cc, that is cubic centimeter, or maybe in liter, milliliter. Temperature is measured in degree Celsius, Kelvin, or Fahrenheit. So all these physical quantities has got its own measuring tool as well as its own unit. But when we talk about unit, all over the world we use all these quantities. So in case sitting in India, if I say my weight is 50 kg, and someone in America listens that there is a fellow in India whose weight is 50 kg, and if he doesn't know what do you mean by kg, he will say, no, I don't know what is kg. I need to know about pounds. How much pound your weight is? If he asks me in pounds, then I don't think I would able to explain him the answer. That's the reason the units are needed to be standardized. So we use SI units for every physical quantity. What we use? SI units. Standard units we use to measure any physical quantity. So what are these SI units? Now imagine for height or for distances, meter is a SI unit, not centimeter, not kilometer. For weight, kg is a SI unit. okay, not gram. For time, second is a SI unit, not hour. Seconds is a SI unit. So these are the few SI units that what one should use when put or give some typical quantity in physics. Okay, let's move ahead. Physical quantities or any quantities are of two types. One, scalar quantity, and second, vector quantity. One need to properly understand the meaning of scalar and vector quantity. Now, what are scalar quantities? The quantities which only needed magnitude or a value, or the quantities which can be easily explained by magnitude, called as a scalar quantity. For an example, temperature. Temperature, if I say my temperature is 37 degrees Celsius, is more than sufficient. For distance or for maybe height, if I say my height is 178 centimeter, is enough, is more than sufficient. But if I say that a aeroplane is traveling with the speed 343 meter per second, then you will say in which direction it is moving. It is moving towards America, or it is moving towards Japan, it is moving towards Sri Lanka. Where exactly it is moving? Now here, to explain the direction, we need to give another information about the quantity. Such quantities are called as a vector quantity. That means the quantities which need direction, including the magnitude, are called as a vector quantities. Which are scalar, which are vector quantities? Now, as we say, temperature is a scalar quantity. Measuring distance or maybe height is again a scalar quantity. Weight, I am not going to call it as weight now. I will call it as mass. Mass, yes, it is a scalar quantity. I am purposely not talking about weight because in short time, maybe in 4 or 5 topic, I think in third topic from now of physics, you will understand why I am not calling weight. Weight and mass are different quantities, they are not same. So mass, yes, it is a scalar quantity. So what are vector quantities? So I'll just mention because you don't know about it. Displacement, velocity, acceleration, force, all these are considered to be a kind of a vector quantities. Okay, all these we are going to understand in this topic itself, and the force in the next topic, right? Scalar quantities, as I hope you got it, temperature, maybe even weight or height, weight, mass, sorry, mass, temperature, then distance. All these are considered to be scalar quantities, right? Weight comes in vector quantity. Okay, so right now, if you as you don't know, I'm not mentioning it here, or even you need not to mention. So these all things are enough for understanding scalar and vector quantity. So again I repeat, scalar quantity, only magnitude is sufficient, matlab the value of the quantity is sufficient, whereas in vector quantity, magnitude as well as direction is needed to explain. Such quantities are called as a vector quantities. Clear? You can give these examples, it's not a big deal. Now let's talk about the next part, that is displacement and distance. So I'll just mention distance and displacement. Very interesting concept. Distance is a scalar quantity. ये जो है ये है scalar quantity, and displacement is a vector quantity. Whenever we know about a particular quantity, we always start with its unit or maybe some formula or maybe some symbol. So distance, displacement has got symbol S. S is for displacement. Distance as such, we don't have any symbol, or we normally don't use any symbol. But for the displacement, we use what symbol? Symbol S. Okay, so let us know about distance and displacement difference क्या है. Just imagine this is my house, and here is the school building. So I have to go from my house to the school. So I can go directly from house to the school, isn't it? In this way. Or my friend lives somewhere here. And now what I want to do, I want to go to my friend so that I can give him the book. And then we together are going to go to the school. Right? So now the path which I just now walked on from point A to B and then to S, S is for school. This distance, that is AB plus BS, is called as a distance. And the direct distance AS, I'll write here, AB plus BS is called as a distance. And direct distance is nothing but called as a displacement. Direct distance from my house to the school is called as a displacement. So let's talk about the definition of it. Distance is the length of the path covered. Distance is the length of the path covered. So I went from A to B and then B to S is called as a distance. And displacement is nothing but change in position. So I was here and now I am here. So this is what my change in position is. Now this is called as a displacement. The direct distance is nothing but called as a displacement. Okay, so still I hope it is a bit confusing. So again I will take another example. Okay, so let's take a simple example. Imagine I have a circular track and there is an ant here at point A. So the ant moves from this particular path till here. Here the ant is now B. So what ant is doing? Ant is traveling on this particular path and now the ant is at point B. So how much distance ant is covering? The length of this particular arc is nothing but distance. So do you know how much is that? Is equals to pi r. Because circumference of circle is 2 pi r and it is semicircle. Just imagine it is semicircle, so it is 2 तो गया उसका half मतलब pi r. And distance AB, which is diameter maybe 2r, is nothing but the displacement. Okay, because the ant was here and now it is here. Right? So what is change or what is the direct distance from the initial position to the final position is nothing but AB, and that is equal to 2r, and that is called as a displacement. Clear? Just imagine if any hen is moving or maybe moving in this particular path. Okay, so it was at point H and now it is at point N. So the path what that particular hen has traveled from H to N, the distance of that path is called as a distance, whereas the direct distance from H to N, direct distance from H to N, this is called as a displacement. That green color is displacement and this red color is nothing but distance. Idea clear? Getting? I hope you understand. Let's take a simple question for this. एक simple question लेते हैं हम लोग, ठीक है? Just imagine I am at point A This AB distance is 3 centimeter of 4, and BC is 3 centimeter. 3 meter I can take meter. So I went from A to B and then B to C. What is my distance? That means how much distance I covered. So my answer is 7 meter. So what is my displacement? What is my displacement? Isn't displacement is nothing but the distance from A to C? How much this distance is? Don't know. So do we need Pythagoras theorem here? Yes, we need Pythagoras theorem here. So if I'm talking about Pythagoras theorem, I get AC square is equals to AB square plus BC square, which will be 4 square plus 3 square. 16 plus 9 is 25. How much is AC then? Yes, exactly. It is 5. So how much displacement is nothing but 5 meter. I hope you understood the example, right? We'll talk about another example. थोड़ा सा difficult करते example, ठीक है? So imagine there is a circle, there is a rectangular track around a typical garden. There is a garden inside it. ये जो है ये garden है. And the person is at this point right now. It moves on the track, goes here, and then comes here. So here is at A, then it went to B, then goes to C, and then goes to D. This garden dimensions are 20 meter, 200 लेते क्या थोड़ा सा छोटा हो जाएगा है ना 200 meter and 100 meter. Okay, so it was at A and now it is at D. So what is the distance covered by that particular fellow? It is 200 plus 100 plus 200, right? No? So it's normally is going to be 500 meter is the distance. How about displacement? So I hope now you can tell me the displacement is a direct distance from the final position to the initial position. So the distance is, a displacement is nothing but equal to 100 meter. Direct distance, direct displacement. Okay. Now imagine, just imagine, now the same fellow which is travel on this particular path is again traveling and reaching at the same original position. So at this point, what is his distance? So he was at A and then now he is at A. The distance is 200 plus 100 plus 200 plus 200. How much it is? 600? Sorry. And now what is his displacement? Now that is quite interesting here. What do you think his displacement is? His initial position was A and the final is as well A. So do you know what is his displacement? Yes, it is 0 meter. No change in the displacement. Right? Is this clear? I just hope you understood the concept, right? So I hope you got it. Okay, what is distance? Distance is nothing but the length of the covered path by the body, whereas displacement is nothing but the change in the position of the body. Distance is a scalar quantity and displacement is a vector quantity. But similarity is both the distance and displacement are measured in a quantity called as meter. The SI unit of distance as well as displacement is meter, right? So we understood distance, which is measured in meter, and displacement symbol is S, which is also measured in meter. So I hope you understood this concept. Let's talk about velocity and speed. Speed and velocity. Very, very interesting. Again the same thing. Speed is a scalar quantity and velocity is a vector quantity. Same like distance and displacement, we have speed and velocity. Even concepts are similar. Speed, we know that already, we have heard about this. Speed is equal to distance per unit time, or distance covered in a unit time is called as a speed. That means if I say that my speed is 5 meter per second, that means I can cover 5 meter in 1 second. So that's what we call as a speed. Whereas velocity is displacement upon time. Velocity, the symbol is v, small v. Unit, let us talk about. Very very important. Simple है, ज़्यादा difficult नहीं है. Distance is measured in meter. Time is measured in seconds. So your unit for speed is meter per second, and the same for velocity, that is meter per second. So velocity and speed both have got a similar meaning, but one is a scalar quantity and one is a vector quantity, right? Speed is distance per unit time, whereas velocity is displacement per unit time. Speed is nothing but a scalar quantity and who is measured with the meter per second unit, and velocity is a vector quantity but measured in the same unit, meter per second. But meter per second considerably is a very small unit. That's the reason normally we use another unit for the speed or velocity, that is kilometer per hour. One need to understand or need to know to convert kilometer per hour to meter per second and meter per second to kilometer per hour. Okay, we will be discussing this in a later part, but because as practically we use this and standard SI unit is nothing but meter per second, that's the reason we need to know to convert one another, right? I hope you are understanding now speed and velocity as well. So I'll just erase this and let's talk about the last concept, that is acceleration, and then we will stop this work. So the next concept that what you understood is nothing but velocity, nahi yahan pe, speed, and it is measured in the meter per second, and velocity, it is measured in kilometer per hour. Of course, velocity is, the symbol is v. Speed is scalar quantity, velocity is a vector quantity, right? So in short, we understood the concept. Now the next one. Imagine I have a bicycle and you have a car. Okay, you have a car. Now bicycle, maybe it is taking some speed, like imagine 16 kilometer per hour. Okay, I'm using different unit, and car is taking 16 kilometer per hour speed as well. So now do you think a cycle and car are working in a similar manner? I don't think so. I know the car is moving slow, cycle is also moving with the same speed, that is 16 kilometer per hour. But in how much time the cycle achieves the speed 16 kilometer per hour? Just imagine, to achieve 16 kilometer per hour, cycle is taking 3 minutes. Whereas 3 minutes means how many seconds हो जाते देखते हैं, 6 3s are 18, 180 seconds. Whereas car can achieve 16 km per hour speed only in 3 seconds. So don't you think maybe the velocity is same, the speed is same, still the cycle is taking more time whereas the car is taking less time. Now what is this called as? This is called as acceleration. Change of velocity, rate of change of velocity, how velocity is changing, how fast velocity is changing. To measure that, the quantity used called as a acceleration. So what is acceleration? Acceleration is rate of change of velocity. Okay, how velocity is changing from 0 to what, in what time it is changing. The measurement of that quantity is called as acceleration. That's the reason the lever in your car which is used to increase the speed called as an accelerator. Okay, because it accelerate the car. What do you mean by accelerate? Increases the velocity. The car is at 0 meter per second, and it reaches its 10 meter per second in a short time. So that is called as a acceleration. So what is acceleration? I am purposely not teaching you definition and all. I am just telling you a simple and easy understanding of that particular quantity. Okay, so from tomorrow we are going to understand the definition and the technical terms and its understanding. But right now we are just understanding the concept. So what is acceleration? Acceleration is nothing but a rate of change of velocity. What is acceleration? Acceleration is rate of change of velocity. Rate of change of velocity. As velocity is a vector quantity, acceleration is also a vector quantity. रेट ऑफ चेंज ऑफ वेलोसिटी मतलब क्या होता है? एक्सेलरेशन का सिंबल होता है ए, स्मॉल ए. तो ए इज इक्वल्स टू चेंज इन वेलोसिटी. तो इट इज वी माइनस यू, उल्टा हो गया, u माइनस वी, बराबर, वी माइनस यू, राइट, वी माइनस यू अपॉन टाइम. v क्या है? फाइनल वेलोसिटी. u क्या है? इनिशियल, इन द बिगिनिंग हाउ मच इट वाज. So change in the velocity per unit time is nothing but called as acceleration. Okay, change in the velocity. कितना velocity change हुआ? From 0 to 16 हुआ. तो that is a change in the velocity. Upon कितने टाइम में हुआ? That is your acceleration. ठीक है, बात समझ में आ रही है? Is this clear? तो just imagine अगर ये 16 किलोमीटर की जगह मीटर पर सेकेंड होता, तो what was acceleration? Acceleration was चेंज इन वेलोसिटी. तो 0 था, 16 हो गया, 16 माइनस 0 अपॉन टाइम, दैट इज 3 सेकेंड. सो इट इज गोइंग टू बी 16/3 इज नथिंग बट माई एक्सेलरेशन. गेटिंग, अंडरस्टैंडिंग? सो दैट्स व्हाट द एक्सेलरेशन इज, रेट ऑफ चेंज ऑफ वेलोसिटी. बट लेट अस फाइंड आउट इट्स यूनिट. एक्सेलरेशन का यूनिट फाइंड करते हैं, चेक करते हैं इसका यूनिट क्या होगा. यहां पे मैं लिखता हूं एक्सेलरेशन. Of course it's a vector quantity and it is symbol is a, right? What is the unit of the acceleration? देख लो, the velocity का यूनिट क्या होता है? It is nothing but meter per second divided by second. So the unit of acceleration is, which is meter per second square. What is the unit of acceleration? Meter per second square. This s goes down and it becomes the square of s, seconds. So the unit of acceleration is meter per second square. Okay. I just hope that you understood the concept of distance, displacement, speed, velocity and acceleration. Okay, still if you are having any confusion, let me know. You can ask doubt on the group directly, as I have already stated. So I'll be adding that in the next video, or I will clear the doubt there and there itself. Fine. So we'll stop this work here. From tomorrow we'll actually work on the technical concept of this. Till then, bye bye, see you tomorrow.